Break-even point analysis, or in some books it is stated as trade-off analysis, and deals with a problem where you have multiple options and they have fixed cost and a variable cost. Fixed cost, basically, as the name suggests, it's a fixed cost. Whether you are shipping 1 item or 1 million item, you have to pay so much, and it doesn't change with the quantity. And the variable cost, on the other hand, changes with the number of items you are shipping. Okay, and idea is you have multiple alternatives, and you are trying to find some ranges where each of these alternatives, let's say, makes sense. Okay, I'm just gonna draw a couple of lines here, and of course these didn't match the drawing, so I'm gonna just adjust it. Okay, this is cost on the y-axis, and x-axis is quantity. Okay, what this tells me is if I'm shipping an item number less than quantity 1, I should use this one. Let's say this is male. I'm just making it up. And then if I'm shipping number of items between quantity 1 and quantity 2, I can use truck. And then if I'm shipping really large quantities, I can use train. Okay, and what we are trying to do is basically find these ranges, saying, you know, if the quantity Q is between 0 and Q1, use truck. And then if it is between Q1 and Q2, I'm sorry, that was the other way around. This is male. This is truck. And then if it is greater than Q2, use train. Okay. Of course, if I know the fixed cost and variable cost of each option, every time somebody tells me a number, I can just calculate the cost of mail, truck, and train, compare them, and choose the least cost option. But if you're doing this calculations many times, you bet you will get bored of this, and it is not really a value-added task. So instead of doing it multiple times, you can just determine these ranges, and then somebody says, I want to have 50, and 50 is, let's say this is 200, you know that you need to ship with mail without doing any calculation. Okay, so here's an example. So there is a manufacturing company, and it has 3 alternatives to deliver their finished good to a region. These alternatives are railroad, company-owned trucks, and private carriers. There are fixed and variable costs associated with each alternative. While fixed cost of these alternatives are $500, $250, and $50, variable costs are $2, $5, and $10 per item respectively. So basically it tells me if I want to ship with railroad, it costs $500 fixed cost and $2 variable cost, and the others as given above. Okay, so what I need to do here, basically compare alternative pairwise and then come up with the graph that I draw up on the top. Okay. If you look at the figure above, what it tells me is at this point the cost of mail and truck are equal, and at this point truck and train costs are equal. This area is basically where the mail is cheaper, and this area, and actually if I was comparing two of them up to the here, would be truck is cheaper. So what we are trying to do is find these points where the costs are equal to each other, and that will be our break-even point. Okay, so let's look at railroad versus company-owned truck. All right, so railroad cost is $500 plus 2 times the cost of basically the number of items that I'm shipping. Let's say it's a Q, and when they are equal, it's gonna be 250 plus 5 times the number of item I'm shipping. Okay, if I move this one here, move this one here, and then arrange it, I end up with 5Q minus 2Q is equal to 500 minus 250, and 3Q is gonna be 250, and Q is gonna be 83.3. So basically, if I was drawing this figure for these two options only, this is company on track, this is railroad, this is 83.3. So below 83.3 I should use company on track, and above that I should use rail. Okay, but I have three options, so this is really deceiving. I should never draw an incomplete graph without calculating all the numbers. Okay, so please don't do that, and do not try to read this single figure. Okay, the next one is railroad versus private carrier. Okay, that is 500 plus 2 times Q is 50 plus 10Q. Okay, again, if I arrange it, it's gonna be 500 minus 50. I end up with 8Q being 450. If my calculations are correct, this is going to be 56.25. Okay, but double check the numbers, do not trust me. Okay, so below 56.25 it seems private carrier is cheaper. Above that number, railroad is cheaper. Okay, again, we shouldn't do that pairwise comparison, but this is what that information basically tells me. Okay, and final one is company owned truck versus private carrier. In this case, 250 plus 5 times Q is gonna be equal to 50 plus 10Q. 10Q minus 5Q, 250 minus 50. Okay, and 5Q is equal to 200. Q is equal to 40. Okay, now I can actually draw the numbers. Okay, you don't need to really draw a very well scaled paper, I guess. What I need to do is, I know there are three fixed costs. This is 50, this is 250, and this is 500. 50 has a very high slope, which is 10, and then 250 is in the middle right here, and 500 is the cheapest per unit. That means it has the least cost. So that is my figure, right? These two intersects at 40. This point is 56.25, and this is 83.3. Okay, so my area is this, and let me also name it. This is private carrier, this is company on track, and this is railroad. Okay. Okay, so this is cost, this is quantity. Okay. Basically, this overall figures tells me that if I'm shipping something between 40, I should use private carrier. If I'm using, and I can use the equal sign in one way or another, or in both, because if I use if I ship 40 with the private carrier or company owned truck, the cost is gonna be equal to, so, but I like putting on one way always. 40 Q 83.3, I'm gonna put the equal sign here. and that is company on track, and every time Q is greater than 83.3, it is railroad. Okay, so if somebody tells you that you have to ship 400 units, you don't need to do calculation, you already know it is the railroad. If it says 20, you know what's the answer. If he or she says 60, you know the answer. So that way you don't have to calculate the cost of rail, truck, or company on track or private carrier every time and then make a decision, which is going to be time consuming.